Well, good evening, everybody. We are joined tonight by Sleeping Warrior and Professor Phil. We'll get into that in a minute. Just do a quick mic check and see if everybody's there. Hello, Sleeping Warrior, are you there?
Yo, yo.
Good stuff. And Professor Phil, are you there?
Yes, I am. Good evening to the people in Britain.
And good evening to you too. It's early there, I believe.
Yes, it is. It's just in the morning, so what have we got? Just after 8 o'clock.
Well, I hope you're nice and awake, ready for this.
I am, but like I said, so I do have quite a busy day ahead of me. But let's see how long we can go.
Excellent, excellent. So, I believe you want to do a bit of a presentation first. Is that correct?
Okay. Yes. Now, let me do this. So I'm going to share my screen.
Okay.
Okay. And before I do that, I'll get this video up, this presentation up. Okay, just bear with me, okay?
Are you going to be playing any sound through the...
No, I'm not. I'm just going to... I've just got a slideshow which I'm going to flick through just for the benefit of the audience.
Okay, no problem. Tony, if you could give him the mic whilst he does his little presentation, and then you two can get into your debate. Is that okay?
Okay, all right, just a minute and I'll just get this started. So, okay, oops. Okay, all right, so hit the screen share and then we'll start sharing. Okay, what can you see on the screen?
I can see myself, so it's all good.
And okay, can you see the screen that I shared?
I can, yes.
Okay, and that says what?
You're showing the Skype window at the minute.
Oh, okay. All right. I'm trying to share the screen.
Yeah, you are sharing the screen. If you minimise now, if you minimise that box. No.
Okay.
Yeah, there you go. Minimise that.
I'll see. Okay, that's my work there. Right.
There you
Okay.
go. So I see what is science. So there we go. So if you're ready to present, I'll pop you on now.
All right. Well, before we actually even get into that, what I'm going to do is I want to talk about the flat Earth movement, the way I see it, and just let you know how I ended up here and why I'm actually even doing this. Well, first of all, probably about a year ago, I don't know, the time flies these days, so I don't know how long it's been since I've noticed on my Facebook feed that somebody was saying that the Earth was flat. So I thought, well, that's ridiculous, I'm going to have a look at it, and then that led into a major rabbit hole of unbelievable underworld of people who actually did believe that the Earth was flat. Okay, now.
Okay, so you see that little... Sorry, just one thing, Professor Phil. You see the little the X on the top right of that little box that's there. If you just click that, if you just click that, it'll get rid of it. There we go. Perfect.
Okay. All right, that's good. Thank you for that. Okay, so so let me just talk about some of the observations that I have from this. And first of all, I find that it's quite toxic, and for that reason, I don't know why that should be like that, because that tends to be a toxic environment when people hold onto beliefs, and no matter what, will not relinquish them, even in the face of evidence. Now, I say that from both the perspective of somebody who believes in the heliocentric model and someone who believes in the flat Earth model. I say that reservedly, of course, the word model. However, well, I think I'll continue to use that. Okay. Now, what I've discovered is a lot of aggression in this discourse. For instance, Anthony's discussion with a couple of graduates just recently. I had a look at that, and I guess that's what prompted me to say, look, let's have a chat. Okay. Now, one of the things that the flat Earth people are saying constantly is that academics, scientists don't want to engage in the discourse, and that's true. And the reason they don't is because of this aggression that's going on, and it does nothing for their careers. You get an aggressive person who has no manners at all. You then have a debate with them. You put what you think is your view on the line, and they spend their entire time just simply attacking the person rather than attacking the idea. In this particular session now, I will not be tolerating any discussion about my career. I will not tolerate any discussion about what I do, because those, as far as I'm concerned, is irrelevant. We're here to discuss the science. And so I will refrain. I had quite a lot to say about Mr. Riley, but I'll refrain from saying any of that. I'll just simply discuss what he says. Okay, so in a nutshell, before I go into what is science, I will just reiterate what I think Mr. Riley thinks, and particularly his method of dealing with this discourse. This is my view, of course, and he'll have his opportunity to argue the point. My view is that he wants to reduce science to the four corners of a contract. That's in a nutshell. So that says that so basically define science within these parameters, and thou shalt not deviate from this at all. Well, science doesn't work like that. It changes, it evolves. It's predictable and unpredictable as well. So one of the things that Mr. Riley says is Einstein replaces Newton, for instance. Let's do that as an example. Okay. In Newton's day, Newton, by the way, an icon of science for having come up with the equations that he did, and on top of that, the calculus, which is no mean feat. So Newton worked out that gravity was pretty much the explanation for almost everything that's in motion that we see around the universe, and explains, for instance, the motion of something that falls if you let it go, i.e. this famous apple that's supposed to have fallen on its head. And a lot of people, I knew a lot of time on this, and came up with some remarkable equations that describe how the world works. And these have been put to the test over and over and over again over the many, many years that Newton has developed these. Used in every facet of life. For instance, it's not by guesswork that the Navy manages to send a missile to hit a target. Okay. These are guidance systems, and where they aren't guidance systems, very, very careful trajectory is worked out. And this is worked out using two vectors for projectile motion, namely a horizontal vector and a vertical vector. And guess what? The vertical vector requires gravity. Now, how does this work with Einstein? So Einstein later on, in the absence of actually to come together, people like Cavendish and Ed had worked out that had done experiments that showed that in fact things fall to the and for all the world that's what it looks like. But there was no explanation.
Yeah, for some reason you keep cutting out every 5 to 8 seconds.
I'll try not to move.
Okay, bro.
Let's see. Yes, so Einstein decided to have a look at this and spent many years doing that. And as a result came up with postulated the idea of space-time, and not just him, but together with Lorentz, postulated space-time, and then how well, if you like, in a three-dimensional space-time, and things that are within its vicinity that are of less mass then fall towards it. Now, looking at that in terms of a let's say looking at that in terms of a quantum level, so we can't actually see this phenomenon taking place except by a demonstration of something that looks like it. Excuse me for a second, I'll get rid of that. Okay, probably would draw a laugh, I would imagine. Okay, so for all the world, even though we can't see what Einstein proposed, we can't actually view this. It's a model that he describes, and I'll talk about models later on. It's a model that he describes how things happen. It's tested, by the way, and was tested famously by Eddington during an eclipse. So this isn't something that was just dreamt up by Einstein and then everybody said, "Yay, that works." So therefore, it is what it is. Okay, and again, I will discuss that more fully in the models. So, in a nutshell, this is how it works. For all the world, that's you and me, when we observe things, they look as though things are attracted to each other. When we do experiments, like Cavendish did, and like the thousands of times that's been repeated in universities all over the world, it looks for all the world like things are attracted to each other. Now, that particular attraction actually comes with some very, very precise formulas which work. In other words, you can use them to predict, and you can use them in experiments, and they work. So this is Newton's laws, Newton's universal laws of gravitation. So that's been shown on various platforms, to death. So this is the one where the force of gravity is equal to the constant g with the two masses multiplied over the square of the distance between them.
Are you actually changing the slides? Are you changing the slides here, or have you still got it on?
I'm not changing slides yet. I haven't got back to it, so I'm almost here at sort of at the intro.
Okay.
This is what I'm doing.
Yeah, that's fine. No problem.
Okay. Now, the other thing that Mr. Riley says, which I have issue with, and that is that he says that we're stuck in the current science, and he uses that word quite a lot, which is kind of ironic, because he says current science, meaning that it's possible for it to change. And on that point, I agree. It will change. We get better and better tools. We learn more and more about the subject, and our view of how things work does change. Okay. Also, the academics are given quite a good deal of intellectual freedom. So things that they'd like to pursue their own hypotheses. For instance, the university has a string theory department, electric universe department, multi-universes, people studying them, people studying wormholes, and then any number of things, even stargates, and you name it. Okay, nobody says you can't study something. Nobody says that you're stuck in a particular paradigm. You go off, and if you come up with something different, everybody's going to give you the accolades that you deserve. Okay. The other thing I want to comment about that video, and I'm using that as the evidence that Mr. Riley tends to say a lot. So in other words, I don't believe it, so therefore it is not true. Okay. All right. So now I'm going to start the presentation on this slide presentation, and the first one is, what is science? Okay. So first of all, truth and science are incompatible. So let me explain this. Truth is truth, and it cannot be changed or disregarded. You can't argue with truth. Science always changes, sometimes in a very big way, and sometimes just gradually. In terms of what that means is, for instance, in a very big way, Einstein was able to show something that nobody really knew, and that is what gravity actually does, how it actually happens. Although, obviously, everybody knew by then what it does and how to measure it. Okay, so real and truth are not addressed by science. These are individual assertions. Okay, so the idea that is real, the idea that something is truth, is not addressed by science. Science is about getting models. Science is about, let me go on to this and say, okay, sorry, I should have probably gone to this first. Okay, for example, I accept the globe model for many reasons. That's me, I'm talking about. And the best of these reasons is the footage from cameras that we put on board our rockets, for instance. So there's thousands of reasons, but this is probably as good a reason as you're going to get. So I have very intimate and personal experience with this. So because you don't work as a scientist like I do, then you only get to hear about science when things go right. I'm actually not sure why I even wrote that, but nevertheless. Okay, and I assure you, you're wrong, that I am wrong much more often than I am right. God, I should have read this. Okay, so in a nutshell, science is never about truth. Truth is the domain of religion. Just goes to show when you're writing stuff early in the morning, like 2 or 3 o'clock, it's probably not a good time. So what is science then? So science is essentially the pursuit of knowledge, and we want explanations for what we observe. And the scientific method has long been shown to be the most reliable way that leads to the most reliable, coherent explanations. That's it in a nutshell. So a series of coherent, unifying explanations supported by evidence and testing and predictability form the theory. In other words, a model. Okay. Coherent and unifying are similar adjectives used to describe explanations. It specifies that explanations need to account for all observations simultaneously within given parameters or limits. For example, the current gravity model has limitations at the very large and very small domains. But in everyday life, it explains all the observations and makes astonishing precise predictions. Now, I should have qualified that by saying the current Newtonian gravity model. A set of explanations is not a coherent model if these explanations cannot account for some of the observations. Okay, science would reject a model that contained explanations that fail to account for everyday observations. So let's have a look at what's here. Okay, so science would reject a model that contained, I think I said that. So how does the scientific method work? I guess is a good question. Right, there's many iterations, I beg your pardon, of the scientific method with variations on what must remain a dependent variable and what is classed as an independent variable and how they handled. So this is one of Mr. Riley's pet things. So within his four corners of the contract of science is a definition for what is dependent and what is independent, what can be and can't be dependent and independent variables, and lo and behold, anybody veer from that. I should point out that there are many different ways of looking at independent variables, for instance, and really the focus is if those things change, that independent variable changes, then that's really pretty much what you're after. Whether or not you physically change it or whether it's an observation that you make that's changing is not that relevant. Anyway, essentially the basic rules are the same. Number one, record the observation. Pardon me. Number two, form a hypothesis. So it's like an educated guess about what might be happening. Okay, this is called the alternative hypothesis. And number three, you formulate a null hypothesis, which stipulates the conclusion if the alternative hypothesis is rejected. For example, H1, the Earth is flat. So if we reject that, as I would, for all sorts of reasons, as I've mentioned before, then I would accept the null hypothesis. That is, the Earth is not flat. So we accept that. Number four, we collect evidence and test this hypothesis. Number five, test hypothesis and predictions using this hypothesis. Use mathematical modeling to verify data, such as valid statistical methods that show us that the data is statistically valid. For example, that it didn't turn out to be a fluke. We test all the above over and over to ascertain precision. Okay, so precision and accuracy, as you probably know, are two different things. If you think about it, if I keep shooting at a dartboard and I always hit a particular spot, but it's not the bullseye, then I would call that precision. And if I hit the bullseye, then I would call that accuracy. That's kind of what the difference is. So in science, we mainly are looking for precision. Okay. Okay, so if precision cannot be attained, H1 is rejected. That's the alternative hypothesis, and H0, that's the null hypothesis, is accepted. Okay. So to form a new hypothesis or check that the experiment was valid is what you would do. Number 8, write up a paper and include all raw data and all statistical model used plus all of the conclusions. Number 9, submit all the above for peer review. Number 10, if peer review finds fault with the experiment or data, then experiments and observations and conclusions and data must be repeated and go through the process again. Number 11, if peer review finds in favour, they accept it, then wider testing is encouraged to ensure the hypothesis conclusion accepted. And at this point, okay, the hypothesis eventually is accepted as a scientific theory, provided all the thousands of people who are trying to debunk it cannot. Then industry begins to use the model to develop a wide range of industrial and social applications. So we don't do this for nothing. There's always, when we apply for a grant, we always have to stipulate in what way society would benefit from the grant, and in what way would society benefit from the research. All right, for example, when Faraday perfected using magnetism to create electricity, Edison tells Tesla, oh, I went too far. Where did I go? Okay. Here we go. So Edison, Tesla, Watson, GE, etc., they jumped on the bandwagon and started making electric applications like electric generators, electric motors, alternators, and more. So as a result of Faraday's work, among others, so not just him, worked out that if you have a tube and you throw a magnet down the tube, and the tube is encased in a wire, wire coil, then electricity will flow through that coil. Another example is discovery that led to the understanding about the Earth's magnetic field. Number 3, this discovery led to a swathe of instruments that measure all manner of things by using electricity and magnetism. More examples are audio speakers that came from that, microphones, transformers, trams, trains, Gauss meters, all thanks to Faraday. That is science at work. Conclusion. Saying science is a religion in light of what you've now learned is absurd, so stop saying it. Saying scientists are wedded to their view of the world is also absurd, given what you now know about science, so stop repeating that nonsense. Science does not subscribe to notions of truth. Truth cannot change or evolve. Truth is limiting. If we say this is the truth, then we've got nothing more to look for, which is nonsense. It's never going to happen. Even as we speak, Einstein's work is being refined. And at some stage, somebody or some group is going to come out and say, hang on a second, this is in addition to Einstein's work, or actually refutes it. So finding evidence is not necessarily an indicator of truth. Okay, so what it is evidence. It's the evidence, all of these bits of evidence put together, that allows one to make a conclusion. So the evidence can also include predictions, making predictions, doing experiments that work, industry, creating objects that work, creating computers, creating iPhones, all of these work. How do we understand the quantum world? How could we possibly put together the microprocessors and things like that we do? The doping of the silicates and to be able to produce the microprocessors that we have. The idea that this is all religious is absurd, okay? And it changes. I think that's probably, if I was going to give you a single message about science, science is models that change. There is no single thing that says this is the truth. Okay. Science is about the coherent model that includes explanations that match observations and makes predictions. Science encourages change and improvement. That doesn't sound like a religion. Okay? We want things to improve. We want to learn more. I don't know a fraction of what I would like to know. My biggest bear in life is that I'm 65 years old. So I'm approaching the twilight of my life. At this stage, if I could just hang on to my mind, I would be half happy. I know I'm not going to hang on to my body. But if I could hang on to my mind long enough to see this change. So this is my message. Stop complaining. Do some actual science. Put your work up to peer review if you believe in it. Okay. And you do that and your work. I'm talking about the people who are in the Flat Earth in this group. I'm talking to you. Do your work. Don't complain. Don't fight. Don't be aggressive. That does nothing for what you want to do, what your cause. All that does is pit people against you. My advice to you is to get your stuff done, put it up for peer review, get the world to look at it. And eventually it gets to reach the highest respect. You know what? They might even call it a theory at some stage. Okay, right, so that was this one on what is science. I'll quickly go through the other one. Let's see if I can get it up over here. Okay. All right, so I'm going to slideshow, and from the beginning. Okay, here we go. All right, so now let's have a look at this specifically from a flat Earth point of view. So the flat Earth model. Again, I said that I'd say that reservedly. So exactly half the Earth is in daylight and half is in darkness at any time. So I'm postulating that this is impossible on the flat Earth model without the sun having a movable lampshade. So the fact that it's half the Earth is in daylight and half in darkness is unquestionable. Okay, so this we agree. So in order for the flat Earth hypothesis to prevail, you must be able to come up with a model that shows this: half the Earth in daylight and half the Earth in darkness. Now, the issue here is you have to be able to do that with a round sun, because again, whether the sun is a disk or whether it's a sphere, one could debate that. However, I doubt you could debate that it's round, and I doubt that you could debate that it shines a round configuration. So you've got to work out how on earth you could, pardon the pun, you could make that a semicircle. Okay, so then, well, I mean, there could be two suns. All right, so I'm not sure how that model would work, but I'm open to, you know, come up with something. You never know. Maybe there's two suns. All right. Number three, the sun's speed doesn't change per hemisphere, depending on which seasons there are. For example, the sun does not traverse the continent of Australia any faster than it does similar sized areas north of the equator. Okay, so in order for the sun to traverse the southern hemisphere on the models that I've seen, put it that way. Okay, so again, many flat Earth people are not claiming that they know about a model. That's problematic in itself. We'll get to that. However, the ones that are saying that the flat Earth is a disk, which I probably would have gone there myself, except that I would have done some more work on it and then realized that there's some issues with that. Okay, so the sun would have to go about 3.5 times faster in the southern hemisphere, say over Australia, than it would have to, say, in Britain. And even then, I did some calculations, and it actually would go even faster in Britain than it would, than we know that it does over the equator at the moment. So when you look at the latitudes, it's very simple. Just look at the latitudes and then use 2 pi r for the circumference, and you'll see what I mean. Multiply that by time to get a distance and a velocity, sorry, and you'll see that it doesn't work. Now, during late December to the end of the first week in January, the sun circles Antarctica at around 20 degrees from the horizon in a 24-hour period. Okay, so that is, the sun does not set for at least 2 weeks. This is not news. There are thousands of people who go there all the time. I was there in 1975 through 1976, and it is. So I'm not saying the Earth isn't flat from that perspective. I'm just saying that whatever model you decide that you're going to come up with must include this simple fact, this observation, and that is that the sun rises in the sky, stays up there around about 20 degrees, and for about 2 weeks before it gradually starts setting, and then it'll set for 10 minutes, 15 minutes, half an hour, and then eventually, by the time you get to June, it doesn't rise at all. So it would be just rising. Right now, you'd get some significant periods of daylight, not that much though. Okay, all right. So again, this is doing slides at the middle of the night. It's not good. So what force is applied to make the sun move, and what keeps it moving? So the heliocentric model talks about gravity as the means for which things move, and because of that, it doesn't require any special energy to make it move, other than gravity makes it move. So it doesn't require any propulsion energy. Okay, so this would have to be in the model that would be produced by the people who do the flat Earth. Again, I'm not saying that that the movement of the sun is a reason for disbelieving the flat Earth. I'm just saying that when you do come up with a model, then your model must include the fact that there doesn't appear to be any propulsion for the sun. So what is that propulsion energy that's happening that makes the sun move? And not only that, the sun then has to track differently in the winter around the Tropic of Capricorn, and then differently around the Tropic of Cancer, and then differently about the equator. So what propulsion causes it to move from one track to another? Now, Mr. Riley has come up with something. On one of his arguments with me, spoke about quantum levitation. Well, I did answer that, Tim, and so I hope it's not one of the things that he's talking about. Although, as a scientist, I can't discount anything. Perhaps there's a form of quantum levitation that I don't know about that might make this happen. Okay, come up with the experiments that show it is. Yes, we've seen that work on a macro level, tabletop level, if you like, and but there's a lot of hoops to get over to even make it do that. On a table, including temperature, which would have to be very, very cold. So, how that happens, how the sun gets to go around, well, okay. Come up with a model for that. I'd be interested. I'd be the first one to help you out with the maths if you need any help with the maths for that. Okay. Given that the sun must change velocity on the flat Earth model, what force is applied that enables this to happen? Okay. All right. So I think I've mentioned that. And why are tides independent of the day and night? And how are tidal heights and lows, their magnitude and time, predicted on the flat Earth model? So the flat Earth model would suggest, again, I don't know this for sure, I'm just going by what I've seen, and that is that it seems to me that all of the seas are encapsulated in the middle of a disk, and on the outside of that disk is apparently the continent of Antarctica. It's problematic, of course, in terms of the 24-hour sun, but never mind. The model you would need to come up with, that you need to devise, must include predictability for the tides. How high the tide is going to be, and also and what times, and what's causing this swish swash on this flat Earth. So in other words, you're moving, is something moving the disk so that the liquid in the Earth moves with it, or is it actually the moon or the sun causing it? Is there something moving there that's applying a force to the water, if you like, that makes the tides go in and out? And that's kind of problematic, because if it was like that and it was like a swishing motion, I'm thinking that all the eastern shores would be at low tide while the western shores are all at high tide, and then all the western shores would be at low tide and all the eastern shores would be at high tide. That kind of doesn't happen. So maybe it's not a swish swash backwards and forwards, left to right. Maybe it's a circular type of switching backwards and forwards, which might explain this Coriolis effect with the clouds. That's interesting. Could be worth a look at. Maybe there's something that flips the disk in a circular motion, but only just tiny, just enough to make the water swish backwards and forwards. Well, okay, I can think of a whole bunch of reasons off the top of my head why that might not work, but look, give it a go. I mean, it's a science. You're free. Give it a go. No one's going to criticize you for wanting to give it a go. Okay? You'll be criticized if you come back and say, this is actually the truth. The switching and swashing, it happens in a circular motion. This is the truth. Then people like me will criticize you. All right? I'll never criticize you for suggesting that might happen and then wanting to look at it. But I will if you come back and tell me that it's the truth, because then I'm going to ask for some evidence, and then you're going to have to show me the calculations, and then you're going to show me the peer review. It's kind of how it works. Okay, so hey, when standing in Mumbai, which I go there a fair bit, so I'm very, very familiar, and I'm looking south, and then in Melbourne where I live, and I also look south. Okay, actually not Mumbai. No, Mumbai doesn't work. I'm thinking, no, that's an error. That was meant to say Cape Town, but I don't know why I wrote Mumbai. Okay, my point about this one here is if you're standing anywhere, let's say in South America, say in Cape Town, South Africa, which I lived for a while. So if you're standing in South Africa and you're looking south, you can see the Southern Cross, and also you can see the South Celestial Pole Star. Okay, and then if you're in Melbourne and it's also still dark, so it's still at night, and you look down, you can also see the Pole Star, and you can also see the Southern Cross, obviously. Southern Cross is our flag. Now, the point I'm making is that if you flatten the Earth, then just looking at that Gleason map puts these about, and Cape Town and Melbourne be probably about 120 degrees, 110 maybe, 110 to 120 degrees away from each other. And yet, despite this being 120 degrees away from each other, we're looking at the same stars. Again, I'm not saying that this is a reason for the Earth not being flat. I'm just saying that when you do present the model for a flat Earth, this is one of the things that people are going to ask you. They're going to say to you, how come I can stand in Cape Town at the very same time as somebody standing in Melbourne and see the same stars? Okay. You would have to explain that. Okay. North Pole to the equator, 6,308 miles. Okay, therefore the distance around the equator, the AMAP, is actually 39,639 miles. So I hear look, I could be wrong about this math, but I've got a feeling that it's right. So if the North Pole to the equator really is 6,308 miles, and I think it is, well, I had to look at that on the internet. I think it is. And if it is, then pick anything on the equator, for instance, any city on the equator, and Google the distance from the North Pole, and I think you'll probably find it'll be right. So if that's right, then you can see just from that alone, 6,000, no, that's wrong. Okay, forget about this slide, it's wrong. Okay, the distance from the North Pole to London, 2664.7, so that's probably right. And then if that's 2,000, I'm not sure about the maths, so I'm not going to quote it. Turn that off.
May I ask how long's to go on these slides?
Just very, very short. We're just about where the end now, so I'm going to pass these slides. I forget about the maths. We'll come back to that. So, all right. But the point I'm going to make is, and this I am sticking to, and that is that if the sun was in a flat Earth model was actually now over Australia, which it is in our summertime, then in order for that to happen, it would have to be racing across the sky. And I would, across the 106 kilometres that Melbourne is, where I live, east to west, the sun would be whizzing by in about 20 seconds. So I wouldn't be able to get my car to keep up with it. Okay, conclusion. So we're nearly there. If you're confident of a model that explains all these things adequately and simultaneously, then we can move on to more complicated observations, for instance, like gravity, planetary motion, etc. Thank you. That ends that. So I want to get back to this. So I presume I'll go here. All right. Okay, so that concludes what I have to say.
Okay, well, thank you very much. Tony, do you need to do a presentation, or are you ready to just get straight into the debate here?
Yeah, I'm going to do a presentation because, to be honest, the amount of slides that the guys presented there, really, he should have given me these so that I was able to, get all the evidences together, because to expect me to respond to that amount of slides with that amount of assertions ad hoc on demand without verbal, with it being just verbal only, if he wanted more than just verbal explanation, it really isn't fair. He should have disclosed this beforehand, because I would have been able to give comprehensive evidences that go against the assertions that are presented, or to explain the assertions that are presented. But without having that advanced disclosure, I'm having to do it purely by voice, by explanation, by the dialogue. And that's not really the best way to do it, but it's the best I can do with what I was given. What I'm going to do is make my presentation the way I was going to do originally. Ranty, I'm going to screen share in one sec while I get my first slide up. Okay, so let me screen share, Ranty. Let me know when you see it. And if you wouldn't mind sticking yourself on mute, because you have a lot of background noise, Phil.
Okay, yes, you are on. You are sharing right now.
Okay, so Ranty gave me the message that we asked at the end of the hangout yesterday with Toady, and this is an extract from the message, and it really, I'm going to go through this.
Listen, I object to you showing my private emails to that between me and Ranty on this. If you don't remove this right now, I'm leaving.
Well, leave. This was asked of you to provide this before you joined, so that I had an idea of what you were going to be presenting.
No. Sorry, you are not at liberty to disclose my private emails.
You were asked to provide some information.
Excuse me, did I not ask you to be respectful?
I am being respectful. You were asked to provide.
Please remove my private emails, otherwise I leave. Now, Ranty.
Yeah, if you would like to, Tony, if you want to skip through to the next couple of slides or something, and just forget this one for now.
I believe if you discuss my private, if you discuss me privately in any way, all my private emails, I will.
Okay, he's taken it. Okay, he's taken that off, so he's going to go on to slide 2.
Okay.
Sit yourself on mute, sir. I didn't interrupt once. I accept your criticism. I've removed it.
Good.
That doesn't change the direction that this is going. So sit yourself on mute and let me respond to your points.
If you discuss me personally, I'm going.
You leave.
You can discuss my points. You can discuss the science. You cannot discuss me or my career.
You can leave if you wish. This is going to happen whether you let me or whether you don't. You can leave. Fine. So, the previous slide that he didn't want me to share, even though he was asked to provide some information, he wanted an apology for showing disrespect. And I don't feel as though there's any apology due for being disrespectful. And I'm going to cite some of his messages to me to justify why no apology is due. If he expects an apology for disrespect, it works both ways. Now, these are some messages from my comments recently from this guy who's now expecting or wanted an apology based on a lack of respect. He describes me as a narcissist. Is that what it takes to be a flat earther? A willful display of dishonesty? I'll make a video featuring his stupidity without him. My last lecture covers most of the shit he keeps banging on about. Next one. I won't... hang on. That's the next one. By the way, Anthony, you're a goose. They were not academics. Academics are teaching staff like professors and lecturers. I said academics are also university students, not just the teachers. If you went, you'd know. No, they are not. You just like to make up your own definitions. You moron, I'm a professor at a university. Well, if you were a professor at a university, I would expect you to understand that the meaning of the word academic does include the scholar at the university, not just the teaching staff. We were all academics when we went through university. Everybody gets described as academics. I don't know why you're taking issue with my definitions. Everybody understands the meaning of that word. My question is, how is it the UK seems to have more than its fair share of imbeciles? And then in reference to David Copter, or whatever that name is this a new word for really stupid in the fact that he's subbed? I said, but you can't science. Just like the idiots that I met from Liverpool recently, you preach orbits but have jack evidence that they are true. Theoretical physics is worthless without experiment. Would you like citation? And of course, I cite this regularly from Scientific American, from Abraham Leob in 2018, theoretical physics is pointless without experimental tests. So at this point, he's asking for an apology, and if he's going to expect an apology or ask for an apology based on disrespect, it does work both ways. I wasn't rude to you. I didn't agree with you, but I didn't swear and I didn't cuss at you. However, the apology request has been denied on the basis that you don't actually deserve one. Next point. I cite Scientific American because it reads really well. The guy, that particular webpage, it writes pop science and it gives you an overall feeling of what's going on. He didn't tell me what he was going to be talking about in his pre-advance or what the message, other than to reference me to a video which was referencing Einstein and Newtonian gravitation. And I reference Scientific American basically because they claim that they cited original work from Albert Einstein. That's credible to me. It might not be true, but on face value, I take it as credible. And one of the most important parts of scientific method that this guy, my friend here, isn't getting right, is the requirement for experiment. Experiment is the linchpin that science revolves around. John's banged on about it time and time again. Experiment. You can hear John talking in the background. It's experiment. It's almost like George W. Bush when he was saying terrorists, terrorists, terrorists. John Quantum Eraser constantly says experiment all the time. And that is the reason why a lot of this stuff that we talk about in this topic doesn't satisfy science. It isn't the scientific method. It's lacking in experiment because it's theoretical physics. It's nothing more than a lovely story. I'm going to cite Michael Crichton? I'm not quite sure how you pronounce it. Crichton. He's a Nobel Prize winner. He's a best-selling novelist person as well as numerous other bits and pieces. Here's two citations that this guy says. Science is nothing more than a method of inquiry. The method says an assertion is valid and merits universal acceptance only if it can be independently verified. Secondly, he says, historically, the claim of consensus has been the first refuge of scoundrels. It's a way to avoid debate by claiming the matter is already settled. When you hear the consensus of scientists agreeing on something or other, reach for your wallet because you're being had. Let's be clear. The work of science has nothing whatsoever to do with consensus. Consensus is the business of politics. Science, on the contrary, requires only one investigator who happens to be right, which means that he or she has the results that are verifiable by reference to the real world. In science, consensus is irrelevant. What is relevant is reproducible results. Now, in the context of Einstein, there is no scientific application to his work. All of it is observation-based. Experiment, there is none. It's all based in maths. None of it is based in real world. At least Newtonian mechanics had the application of stuff in the real day-to-day world, and we all know that Newton didn't want gravity ascribing to him. Anyway, scientific method. If you go to Google and just type in scientific method experiment test, you'll find numerous different citations, and they're all over the place. You can find these everywhere. And the most important part in this citation from Rochester is that the performance of experimental tests of the predictions by several independent experimenters and properly performed experiments. Experiments got to be there. If it hasn't got experiment, it's not science. This website states the conclusion to be, while the method appears simple and logical in description, there's perhaps no more complex question than that of knowing how we come to know things. In this introduction, we have emphasized that the scientific method distinguishes science from other forms of explanation, Einstein, theoretical physics, because of its requirement of systematic experimentation. There's no getting around this. Experiments got to be there. Lawrence Krauss, the ultimate arbiter of truth is experiment, not the comfort one derives from a priori beliefs, nor the beauty or elegance that one ascribes to one's theoretical models. And the reason why I'm focusing on the experiment bit is because our friend here referenced the models, and he puts a lot of weight on models, but this encapsulates the essence of why our friend here is wrong. The ultimate arbiter of truth is experiment, not the comfort that one derives from one's a priori beliefs, nor the beauty or elegance that one ascribes to one's theoretical models. It's not about models at all. Science is not about models. You can use them to predict what you think might happen, but ultimately, it's not about models, it's about experiment. Without experiment, you have literally nothing. You just have a story. So I've got a couple of citations here from Professor. One's from, this is to do with the importance of experiment. And what I'm going to have to do here, I thought that was going to take me straight through. Perhaps not. Let me get a browser up quickly. Bear with me. I'll just copy and paste into here. It should be queued up, and I'll put this sound through on Voicemeeter. Bear with me. One's from, this is to do with the importance of experiment. And what I'm going to have to do here, well, that was going to take me straight. So, oops. Needs 15 seconds. Here we go. Somebody needs to be on mute, guys. Okay, so Professor Shankar from Yale University. Listen to what he actually says about experiments. So it's only about 10 seconds. Hang on a sec, it's a bit low.
Experiments. That's what I want you to remember.
Ranty, can you hear that?
Yeah,
Okay, so
get a bit of feedback though.
For some reason, something's changed on my PC and I'm not getting the sound through. So what I'll do is I'll just open the transcript. 15 seconds in, he says, yes, somebody said it's the experiments, and that's what I want you to remember. The only way things change in physics is experiments. The only way things change in physics is experiments tell you something's wrong with your theory, and if in the end your theory does not agree with the experiment, it's over. It really does have to be the experiment. You can't have a model. A model doesn't go far enough. Asking to do a model or to create a model isn't going far enough. It's a lovely prediction, but it isn't giving you the necessary science that we expect, that we demand, and indeed scientific method demands. So here we have Mr. Feynman, 33 seconds. He says, there we go.
Hang on, somebody's got the Hangout link on in the background. If they could mute that Hangout, that would be great.
Yeah, I think our friend needs to mute himself up because I can hear his background. So basically, what he says is, when we compare these computation results to nature, or we say compared to experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is, in this case, how beautiful your model is. It doesn't make beautiful your guess is. It doesn't make even about how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it. Again, it's reasserting the point that it has to be experiment. Max Planck, a Nobel Prize winner, 1918, 3 years after Einstein's theory of relativity. He is, got a citation from him, says, experiments are the only means of knowledge at our disposal. The rest is just poetry, imagination. And that's where that citation comes from. Now, the reason why I addressed all that is because I was told in the previous message that he's asked me to remove off screen because he said it was private. He was asked for it. Is that he said
it's you, Tony? You're playing it in the background.
Let me have a look. I've got about 50 million windows open. Let me have a look. Oh, it's there. There we go. Is that better? All right. So the reason why I brought all that up is because I was of the understanding that we were going to be talking about Einstein and Newtonian principles for gravitation, because that was what the message that he made me remove off screen said. That's what he was going to talk about in the video. Anyway, so really I've kind of done that like without any direct reference because I didn't get this information before. So now what I'm going to do is talk about the Einstein. Hang on, I don't know whether I should even talk about this in the context of Mr. Phil Bill. Right, let's go with. He didn't really address it. Let's deal with these final two slides. All right, so we have. Let's just get this. Let me just think here. Yeah, I'll go with this. Copy this one. Now I'm going to cite this because our friend here spoke in great detail with regards to models, and what he says in this one, something's changed on my PC sound-wise. I'm not quite sure what's changed, but I need to get to 48 seconds, so let's get to the 48 minutes. He says, my purpose of examining you is not to see if you are any good at doing calculations. We expect that you do know how to do calculations, and you know that you know the mathematics wouldn't be here if you didn't know the mathematics. All right, so we fully expect you to be able to do that. So I'm not here to test your fluency in mathematics. I'm here to test your understanding of the models, okay, and your application of those models. All right. Now he claims that this is being done in a university environment. I'm not satisfied that this is really a university environment. It might be. It doesn't seem that way to me because look if you look at the date it was published, the 5th of September 2019. In universities they don't use whiteboards anymore. If they do use whiteboards, something's not quite right there because they all use at least OHPs, and if they don't use OHPs, they use electronic display, like I can't remember what the projector style things where they're all linked up to computers. It seems to me that this was done literally yesterday, just almost as if it was for this discussion that we're having now. But what's worse on this is when we go to the other citation that I have here, go to there. What I'll do is I'll copy that. That should take me straight through to it. Look at the wording that he uses here, and I don't know whether I'm going to be able to play this because my volume's changed now, but let's try it.
Gravity cannot express it.
Ranty, could you hear that then?
Just play it again. Just play it again.
Yeah.
No, it's a bit low.
Evident in Newton's model.
Right, let's open up the transcript. Something's changed, so I'll have to work out what, but I can't do it right now. But anyway, he says, you can't have force without mass, so mass and gravity are intrinsically connected. Mass and gravity are intrinsically connected. Gravity cannot express itself without mass. This is evident in Newton's model, it is evident in Einstein's model, and it ties those two models together absolutely. It doesn't. Einstein did not kill Newton's model. It complements it, okay? All right, good. Well, Einstein's model was limited to the speed of light. And it was in 4 dimensions, X, Y, Z, and time, whereas Newtonian gravitation was 3 dimensions only, and it was instantaneous action at a distance. They're not the same. It didn't refine, it didn't build on, and as he puts it here, it didn't complement it. It totally changed it. Mathematics is the framework, the baseline for Einstein's. Newtonian's model was based on force, physical, day-to-day, real-world application. And we all know that he said, do not ascribe gravitation to me. But given that this was done like on the 5th of September, which is like 5 days ago, it's almost as if this is written deliberately for a hangout of some kind, because he's literally contradicting all the other science. Nobody else agrees with him that Einstein did not kill Newton's model. It superseded it. It's written everywhere. We've seen in Wikipedia that someone's tried changing it from superseded to refined, And even the moderator of Wikipedia said, nah, it did supersede it, so don't pack it in. Einstein did kill Newton's model because he totally changed the architecture of gravity into mathematics, concepts, models. He removed it from real world application where the cause was unknown, and he put it into maths, because maths is the heliocentric God. Everybody says it's the sun that is the God. It's not. Maths is the God on the heliocentric model. Anyway, so okay, so that deals with the stuff that I thought I was going to deal with. I wanted to get that out as quick as I could because I thought it was going to be relevant based on what I understood the conversation was going to be about. I'll now turn to the points that he made in this particular hangout, and I'll address some of the points that he said in text. I mean, I've took comprehensive notes of what was said here and what was presented, and I'll go through them quickly.
Okay, Tony, just before you go any further, Professor Phil, if you're looking at your Skype screen now, and you can see, because I know that you haven't used Skype very much, but you're actually on mute right now. So if you want to unmute yourself, this little box that you should be able to see, if you look down in the bottom left-hand corner, you can click that box and it will unmute you, and then you can speak and we can hear you. So carry on, Tony.
Yeah, just hold off though. I'm nearly done.
Yeah, sure.
So what I'm going to do is I'm going to address some of the sentences that he said. I took comprehensive notes for these. A lot of aggression in the topic. Yeah, you're right. There is a lot of aggression because there's a lot of disinfo on both sides. There are people that say things that are contradictory to people's views, religions, beliefs, and it triggers people. I'm more empirical. I'm not interested in models. Models are reification fallacies. We know that you shouldn't be relying on models. To claim that you should be making models is nonsense. We should be what we can prove. We should demonstrate it with experiment. We should repeat it. We should verify it. We should prove the cause of the effect. One of the things that Mr. Phil Bell needs to consider is where the evidence is that proves that the Earth is.
And you can call me Professor Phil Bell.
That's what I said, isn't it?
No, you didn't. You said Mr. I've earned my degree, thank you.
So you claim. I'll call you Phil, if that's okay.
That's fine.
Thank you. He says that I define science to within four corners of a contract. Well, a contract doesn't have four corners. I have no idea what this is referencing. I don't know what this is referencing to be able to respond to it, other than it's a non sequitur. It doesn't make any sense.
It's a colloquial term, Anthony. You know that. We both know that. It's actually used in the legal parlance. It talks about what is involved inside a contract, and it's often referred to as the four corners of a contract. You do practice law, don't you?
I've never heard of the four corners of a contract.
Seriously. Okay, maybe it's an Australian thing.
Maybe it is. Anyway, he said that he's talking about the phenomena that he claims that they look as though things are attracted to each other. There is no observed phenomena for gravity. There is no evidence.
There is. Drop something. Drop something. That's an observed phenomenon.
Okay, but my point is that they don't look like they're attracted to each other because helium balloons.
Actually, they do. They look like they're attracted to each other. Now, helium balloons rise. Do you actually know why helium balloons rise? Do you know why?
Gravity's not doing anything.
No, please. Come on. You can do better than that. Why does the helium balloon rise?
Well, hang on. Let me finish making my points, and then if we're going to have a back and forth, let's do that last.
No. It's handy at this point for us to just clear some of these points, okay? So we can come back to it. It's good. I just want to know why a balloon rises. You just mentioned the helium balloon. I'll tell you why a balloon rises. It's because the density of the balloon is less than the air that's around it. So as the air around it heads towards the ground because of gravity, displaces the balloon and causes the balloon to rise. What do you think would happen to that to a balloon if I put too much helium in it? Of course, it wouldn't rise, would it? I could put enough helium in it to make it a liquid. It wouldn't rise. It's got to do with whether or not it can displace whether the air can displace the actual balloon because of this difference in density. Your egg experiment is a perfect example of this happening. This is where you put salt in the water. The salt in the water changes the density of the water. It makes the water heavier. As the water heads towards the ground, because of gravity, it displaces the position where the egg was and forces the egg upwards. It's as simple as that. What you did in your experiment was show us how gravity and buoyancy works. Okay, carry on.
Thank you. The third thing he said was, how can we put together the microprocessors that we have? What are you going to interrupt me again?
No, please go ahead.
What our friend is doing here is mistaking science with technology. It's a common mistake. It's one of the most common mistakes that people make. Reading from this uly.uga.edu website, this is I can't remember which university it is, but it reads, one of the mistakes that many people make in thinking about science is to confuse it with technology. As a result, science often receives either undue credit for the miracles of modern science in one's kitchen or undue blame for everything from overly firm tomatoes to nuclear war. In fact, science does not make things. Scientists develop the understanding of radiation sufficient for the invention of the microwave oven, but neither making a microwave oven nor using it are science. Scientists are in the business of generating knowledge, whereas engineers are in the business of generating technology. People doing science often use sophisticated technology, but science does not require it. Our ecologist observing natural bird behavior and our geologist examining an outcrop neither use particularly sophisticated technology. In fact, the only technology in common to all science is the notebook in which the observations are recorded. In short, science often leads to technology, and it often uses technology, but it isn't technology. And in fact, it can often...
Let me respond to that, please. Okay, so let's just have a look back at for instance, a microprocessor. So this involves doping of the silicates. You understand how a transistor works, okay? A microprocessor transistor. So let's have a look at who are the people who actually worked out how the doping of the silicates work. In other words, who are the people who actually experimented with doping in order to be able to achieve this gate? Who do you think actually discovered the doping materials that's put into these silicon chips? I'm asking you that question. Where do you think that comes from?
You want me to answer who I think?
Yeah. Do you think that the doping materials were created without experiment?
This is a non sequitur. Where is this leading?
How is it? Because you need them in the microprocessors. Do you think the Apple phone that I have over here would work without a microprocessor?
Ranty, this is going to take ages if I can't get through these. I could be able to rattle through these really quick.
All right, go ahead. I think I've made my point. Go ahead.
It's a non sequitur. It's a red herring, and it's an interruption that I didn't interrupt you.
It is to you. It is to you, Anthony, but it's not to people who are just thinking about this. Go on, carry on.
Yeah, but respectfully, I didn't interrupt you once, and you're interrupting me continuously whilst I address all of your points. Just refrain.
No, but I think at this stage we have both said our piece. Now you are going through my arguments, right? So while you go through my arguments, you let me address those things. I think that's reasonable. I didn't go through your arguments in my presentation. That's fine. You're going through my arguments. Let me address them as we go. We both want to reach the same place, don't we, Anthony? And that is to give our audience some information. Correct?
Listen,
so why don't we just do that?
I've been really polite.
I'm not here to fight with you. I'm here to entertain and educate the audience.
Right, but I haven't interrupted you once, and I'd appreciate the same courtesy back. And then at the end of it, if you're not happy with anything that I've said, we can go back over it. It's on.
Okay, go ahead.
I want to get through it because it's late here,
Right.
and it's pretty early for you, but it's very late here.
That's quite true.
So you said,
Yes,
one
I
of the
can
things
see that. Keep going.
at this stage in my life, if I could hang on to my mind, well, that's admirable. I mean, most people do lose their mind at some point, and getting towards the 70s point, that is getting towards the point of losing your mind. I would encourage that. That's good. I hope you can hold on to your mind. You also said to do some actual science. Yeah, I have actually done some actual science. Then you said no one is going to criticize you for giving it, which is making a model, giving it a go. Trust me, everybody in this topic will criticize every aspect of the model that anybody makes, even because that's what we do. We criticize the heliocentric model. Everybody will criticize you for making a model, and I'm pretty sure that anybody that ever will make a model will always be criticized, because that's what is supposed to be happening. Then he says, this is a great contradiction. He says this sentence, and then 2 minutes after says the following sentence. He says, I could be wrong about this maths, but I've got a feeling it's right. So, and then literally a minute later, he says, I'm not sure about the maths, so I won't go on. Forget about the maths. I just love the flowing nature of the contradiction. But anyway, right. So now what I've done is I've picked up all
honesty.
I've picked up all the slides, and I'll go through them as quick as I can to make the points. For example, I accept the globe model for many reasons, and the best of these reasons is the footage from cameras we put on board our rockets. Okay, so I have a very intimate personal experience. That's non sequitur. It's also personal opinion based on your anecdotal evidence that you accept to be true. You don't have very intimate personal experience of rockets unless you can demonstrate that you have got very intimate personal experience of rockets. This is anecdotal nonsense. But if you accept that, that's fine. But that's not strong evidence from anybody's perspective other than your own. Nobody else in the debate would accept that as credible evidence. Because you don't work as a scientist like I do, really. You get to hear about science you only get to hear about science when things go right, maybe. I assure you that we are wrong much more often than we are right. Well, I probably agree with that. So in a nutshell, science is never about truth. Truth is the domain of religion. Science isn't about whatever you're talking about here for what science is. Let's just see what you talk about for what science is, because it's essentially a method. That's all it is. So what is science then? Science is essentially the pursuit of knowledge. It's not. It's just a method. We want explanations for what we observe. No, we want to know the cause for what we observe. That's why we have a hypothesis. The hypothesis is the expression of a cause and effect relationship that we're going to manipulate to prove the cause. That's what the hypothesis is. And scientific method has long been shown to be the most reliable way that leads to the most reliable, coherent explanations. No, scientific method has long been shown to be the most reliable and credible way that leads to a cause and effect relationship. Not reliable, coherent explanations. Explanations are falsifiable. But if you have a valid experiment where you manipulate your independent variable, within that experiment, you prove the cause and the effect. So it's not an explanation. It's a cause and effect relationship. That's what science does. It's that process of establishing that cause. A series of coherent, unifying explanations supported by evidence and testing and predictability form a theory. In other words, a model. A series of coherent, unifying explanations supported by evidence and testing. Right, you need an observed phenomena. You need a hypothesis where you identify your independent and your dependent variable, and then from there you will establish what you hope to be your alternative hypothesis. You will prove that what you believe is causing the effect is causing the effect that you believe you're seeing, or it'll fail and you'll activate your null hypothesis. That's what science is. Anyway, it specifies that explanations need to account for all observations simultaneously within given parameters or limits. It specifies that explanations need to account for all observations simultaneously within. Okay. For example, the current gravity model has limitations at the very large and very small domains. But in everyday life, it explains all observations. That's true. It does explain all observations and makes astonishingly precise predictions. That's not accurate. The Newtonian gravitation models don't work over a continuous period. Orbital mechanics by Newton's gravitation doesn't work. It isn't accurate over even a short period of time. That's not accurate. But you are right to say that in everyday life, it does explain all of the observations. Doesn't prove what's causing it, though, does it? That's the problem. We want to see what's causing the explanation or the effect. Yeah, it's the cause and effect relationship.
May I interrupt you for a second?
For a second.
Okay, good. All right. I just want to address that particular point. Okay. In everyday life, so while it explains what happens, I think this is a matter of semantics over here. So when we say explanations and cause, we're pretty much talking about the same thing. Okay. Carry on.
Not really. If we're going to explain observations, we want to.
That's your semantics, okay?
It's not semantics. No, not really. It's the requirement of science is to experiment.
No, Anthony, you can't. If you want to do good for the flat Earth community, right? Trying to nail science into this very, very limited, narrow range that you have is not going to work. I gave you a list of the things that you would need to do to make flat Earth possible. Concentrate on that. Those are the things. Trying to say, oh, is this the semantics about whether this is science, whether this is not science, is just nonsense. Concentrate on the things that matter. The things that matter are, how do we explain how the sun goes around? Turn that into a model that I can believe. Turn that into a model that yes, it works. By the way, I can make predictions from it. Great. Now I'll say, well, you know what? It's quite possible the Earth is flat.
Right.
Now, I'm not saying it isn't. I'm just saying you come up with a model that does that and I will treat it seriously. But for you to come on here and say, oh, but I'm going to argue with the professor about what science is?
You're not a professor. You don't know what science is. You don't know what scientific method is. I don't believe professor.
You can say that all you like. The proof is on my channel. I put it there. I gave it for everybody to have a look at.
That isn't proof that you're a professor. Listen.
Look, I don't care what you think I am or not, okay? This is not what we're here for.
Ranty, this is my retort. He shouldn't be interrupting me at this point.
I asked your permission and you gave it.
All right, I'm retracting it. Science, by definition, requires observation and experiment. I cited Lawrence Krauss before, and I'll read it again because it clearly isn't going in with you. You're ignoring it. The ultimate arbiter of truth is experiment, not the comfort that one derives, in this case Phil, not the comfort that Phil derives from one's a priori beliefs, nor the beauty or elegance that one ascribes to one's theoretical models. Do you understand how that overlaps directly with what you're claiming is not important?
Are you asking me that question?
Not really. I'll leave it as a rhetorical question. You need experiment, Phil. You can't have just models. You can't have explanations. You can't have logic. You can't have reason. You've got to have experiments. You've got to demonstrate the cause and the effect. So if you think that the cause of sunrise and sunset is Earth turn, then we want to see Earth turn being demonstrated with experiment in scientific method. Otherwise, it's just an elegant theoretical model, Phil. That's why we're asking for where's the proof that the Earth turns. That's what we want to see. Where's the proof that there is a curved horizon that's causing the blockage from the sun at the underside? Where's the proof that there is this thing called gravity that is not a force, but we can think of it as a force, even though it doesn't cause anything? It's the effect of the curvature of space-time. We want to see that there's science that proves these phenomena that we can all describe eloquently. We want to see the proof. But the problem we have is that every time we look for it, we're not able to find the proof, and it isn't there. But you tell us it's there, and you tell us to believe it, but it isn't there. And we want to see the experiment that demonstrates that the Earth's turning. That's what we want to see. Anyway, I'll carry on. So, it's not on this one. The notes, right, so. Science would reject a model that contained explanations that failed to account for everyday observations. No, science would reject a model that failed to demonstrate the cause of the effect that you believe that you're looking at. If it doesn't match the observation, it's not doing what you think it's doing, or you've not got an observed phenomena for you to test in science. You've got to have cause and effect. That is science. So it's not about whether or not it fails to account for everyday observations. It has to be the cause of the effect. Like I said, Earth turn, proving that the sunrise and sunset is caused by a turn in Earth. Science will reject. I think he's just done this one. There are many iterations of the scientific method with variations of what must remain a dependent variable and what is classed as an independent variable and how they are handled. Phil, 2 questions for you. What is the independent variable?
I'm not going to answer that question. Just carry on with your presentation, please.
No, I want an answer. What is the independent variable?
I'm not going to give it to you, so just carry on with your presentation. You're not going to ask a physics professor a question like that, and I'm not going to even dignify it with an answer. So carry on with your presentation, please.
I don't think you know what an independent variable is.
Sure.
So when I'm asking you to talk, you don't want to talk. But when I don't want you to talk, you do want to talk. What's going on, Phil?
Just carry on with your presentation.
I'm going to put it to you in front of everybody that you do not know what an independent variable is. I want an answer, Phil.
An independent variable is the variable that you can adjust. Okay?
Is that it?
Yep.
Goes a little bit further than that, though, doesn't it? It is the presumed cause, and the observer will manipulate it in his test.
Obviously.
Good. At least we got that right, because the girl in Liverpool didn't get that right, and she had a postgrad in chemistry and an undergrad in quantum physics or quantum mechanics. So it's not beyond.
You didn't give her a chance to even think about what she was going to say.
Yeah, I did. I told her what I was going to ask you before I asked it. Would you like to see
your presentation over, or can we start so that I can address some of your issues?
Nearly over. You've got a lot of slides here. This is what you should have given to me. But anyway, the basic rules are the same. Record the observation. Yeah, you've got to observe a phenomena. Form a hypothesis, an educated guess about what might be happening. This is the alternative hypothesis. Now, you've got to identify your independent and your dependent variable. Formulate the null, which stipulates the conclusion for the alternative hypothesis if the alternative hypothesis is rejected. For example, H1, the Earth is a flat. The Earth is a flat. H0, the Earth is not flat. Right? This is not a valid hypothesis, right? There's no cause and effect relationship here. Just saying that the Earth is flat, that is not a cause and effect relationship. H1 would be the sunset is caused by Earth turn. And then H0 would be the sunset is not caused by.
It depends on how wide you want to take it, Anthony. Okay?
Yeah, cause and effect. That's the bit that we need.
You can narrow your hypothesis, or you can widen it. This is pretty wide. Is the Earth flat?
Yeah, it's not valid though. It's that wide. It's not valid. There's no cause and effect. That's not good.
It's all right. I'll leave you to it. You can think what you want. Go ahead.
Collect evidence and test the hypothesis. Test observations and predictions using the hypothesis. Use mathematical modeling to verify data such as valid statistical methods that show the data is statistically valid, for example, and not a fluke. You're just going to manipulate your independent variable. You're going to give it a wiggle. That's what you're going to do. You don't use mathematical modeling. You're going to use that in your prediction. That would be your... Yeah, that's going to be your hypothesis. You're going to calculate what you hope the effect might be.
You don't use mathematical modeling. You seriously are saying that?
Only in your hypothesis. It's the calculation of the effect. You're going to predict.
You come up with data, and you don't use mathematical modeling to deal with that data. Is that what you're saying?
Not in your experiment. No, you do that in your hypothesis.
It's all right, and you believe the Earth is flat too. Okay, carry on.
Not necessarily. I think it could be a bigger ball. I don't know what shape it is. I'm happy not knowing. But what I do realise is it's
no. That's not the assertions that you're making, though. That's the problem.
Yeah, it is. I've said it many times. I think the Earth might be the size of Jupiter. So you're either very, very new to this, or you've not been trolling me very well, because my position's well known. Not many people take my view that it might be the size of Jupiter. I say that because it's definitely not the size of the sphere that we're told we're on. Anyway, test all of the above.
That's not a claim. That you just said definitely. Definitely is like a very strong claim, isn't it?
Write up a paper and include, right, where is the scientific method requirement that requires you to write up a paper? It doesn't exist. There is no requirement to write up a paper. Okay,
carry on.
Submit all of the above to peer review, not required. All you've got to do is perform the test. That is science. If a peer review finds fault with the experiment or data, the experiments and observations and conclusions and data must be repeated and go through the process again, or they just reject it. Or if peer review finds in favour, wider testing is encouraged to ensure hypothesis conclusion is acceptable. There's no requirement to do any publication of paper in a scientific experiment. You just got to perform the test. That's what scientific method is.
No, sorry, that doesn't work. Okay, you do have to write a paper. You do have to put it to peer review if you want to be taken seriously.
So where's citation for that claim? In the meantime, I don't expect you to get it instantaneously, but go and find it right now whilst I finish off the points, and then at the end I'll come back to you and I'll ask you for your citation that requires peer-reviewed paper to be published in a journal.
I don't have time. Anthony, just hurry up with this so that we can go. I've got to go to work, okay?
Peer review request. We'll come back to that at the end, because that's another assertion that you've got wrong. Right. Don't forget, you did take 55 minutes going through this, and now I'm responding to it. But anyway, so the hypothesis is eventually accepted. I think we've done that. Conclusion: saying science is religion in light of what you have now learned is absurd. Science is not religion. Science is a method. Nobody says that science is a religion. Heliocentrism.
Sorry, but half of the flat Earth movement says science is religion.
Right.
I've heard it many times. Maybe you don't. I have heard it.
Science is a method. It involves the systematic experimentation of and observation of the physical and natural world through experiment and observation. That's basically it. I had it on screen before. Saying scientists are wedded to their view of the world is absurd, given what you now know. What does wedded mean? Scientists are wedded.
You don't know what wedded means in the colloquial form.
No.
It means like bound. Okay.
So you mean wed? Is that what you mean, wed?
It means bound. If you ask me what does wedded mean, a good analogy analogy for that would be bound. Yes.
So it's like marriage then.
Tied, bound, those sort of words.
So saying scientists are wedded to their view of the world is absurd. Well, listen, if it was really absurd, why is it that there is no science for an Earth turning, but everybody tells us that the Earth's turning?
I'm sorry, but there is.
Where?
Okay, I'll get that to. I'll get that when you finish yours. I'll explain to you how the Earth turns, and how we know that it turns.
So stop repeating that nonsense. Science does not subscribe to notions of truth. Truth cannot change or evolve. Truth is limiting. There is no more discovery after truth is declared. Science is about models. Science is absolutely nothing about models. It's about testing your hypothesis.
You don't know what models mean. That's your problem.
I know what models mean. No, you don't.
Sorry. You have demonstrated to everybody that you do not know what a model means. Okay?
And you've demonstrated to everybody that you're not a teacher or a professor. When you say professor, do you mean a university professor or do you mean a high school professor?
Oh, God.
Do you mean a university professor?
Finish your presentation so that I can deal with these couple of things that you said with regards to the Earth turning, and then I have to go, okay?
Number one, exactly half the Earth in daylight, half at night time. Yeah, proximity is the reason for that one. Close sun, not far away sun. It's got a limited range. Light doesn't cover all of it because it's not far away. It's close to us. Like your torch lighting up your gate at the bottom of your garden. Your torch isn't going to light up everything behind you, is it? So it's proximity is your answer for that one. Number two, there is apparently...
I can't wait to deal with that one.
Great. So there is apparently only one sun. Most people think that there could be like the possibility of a second sun somewhere. Maybe not in our world, but certainly in the world next to us or the world below us. Maybe, who knows? But we only really see one sun, don't we? There might be evidence of a black sun. I've seen arguments for that, but who cares? This is a moot point. It's got nothing to do with the topic as far as I'm concerned. Sun speed does not change in the hemisphere depending on which season they're in. The sun goes round the center of the pole on one of the models, but that is on an ecliptic path. So the sun maintains a circular orbit around the center of the map, but the path of the sun itself is on an ecliptic camshaft. Effectively, it's called the ecliptic plane. And that's if you ascribe to that particular model. I'm not sure what model I ascribe to. If I ascribe to any, I just realize that it's not a sphere. Anyway. The change of the sun speed doesn't matter. Well, you
think it could be Jupiter, don't you?
It could be. I don't know what it is. I'm happy to say I don't know.
Yeah. Yeah,
So-
that's one of the things that I want to address that you don't know. Okay.
Yeah, I'm happy not knowing that. That's fine. During late December to the end
No,
of the first,
I know, but you keep saying that. Okay.
during December to the end of the first week in January, the sun circles Antarctica at around 20 degrees from the horizon in a 24-hour period. That is, the sun does not set for at least 2 weeks. The sun always sets in Antarctica. They've had to falsify and fake the imagery to make it look like it doesn't. But it
No,
does.
sorry.
Yeah, it does. We've got.
You can deny that as much as you like.
Don't need to.
You
We've
can
got.
deny it till the cows come home, and you do. It's like saying the Earth is flat. All right, it's like saying all of those. You can deny it as much as you can. Thousands of people go there. As a matter of fact, there's a team of my friends who are going there very shortly. Would you? I'll ask them to send some, do some text messages. I'll share it.
What you should do is join Nathan's chat and speak to him about is it Robert Shortman, I think his name was. I can't remember his name now. Nathan will know him. He worked in Antarctica, and the sun always sets. You don't get a 24
No, it
hour.
doesn't.
Yeah,
No,
it does.
for 2 weeks it doesn't. Okay.
It doesn't. So what forces applied to make the sun move, and what keeps it moving? What force stops the moon from falling to the earth when it's at apogee and perigee? When it's at apogee and perigee, it should continue in its motion unless acted upon by a force to pull it back out of its orbit. So when the moon's getting close to the earth, what force is it then pushes it back? Because if it's supposed to be gravity's pulling it towards the earth thing all the time, what's the force that pulls it out of the gravitational force of the earth?
There's a balance between two forces, Anthony. I'll deal with that later.
Yeah, but gravity's not a force, is it? We know that from Einstein. But anyway, given the sun must change.
Garrett, this is one of the things that you keep saying. So let's just address this right now, okay? You keep saying gravity is not a force. Well, I have made this very, very clear. Gravity needs mass for it to express itself as a force. Okay? That's it in a nutshell.
There are numerous citations where cited on Google. First page of Google, gravity isn't a force, so how does it move objects? What is gravity? Fundamental gravity force, one of four. Literally, you can look at all of these citations.
Did you just hear what I said?
Yeah.
It needs
Not a force. It's literally everywhere. Everybody says gravity is not a force.
It needs mass. For the third time, it needs mass for it to express itself as a force. F equals mg.
So, do you not agree with Einstein when he says on his theory of general relativity that gravity is the effect of the curvature of space-time?
Of course, I agree with that.
Right. So, if it's
he demonstrated it with experimentation.
Oh, really? Experimentation's a
Yeah.
key. What was his independent variable in his experimentation?
My God.
Yeah, there wasn't one, was there? It was just an observation, wasn't it? No experiment, just observation.
Some science is done just by observation. Yes.
Yeah, and Einstein's observations weren't experiment, were they? Let's
There you go again with your putting science into the four corners of your contract. It's wrong, Anthony. It's much, much bigger than you think it is, and much more diverse than you think it is.
So, do you disagree with Anne-Marie Hemmenstein, PhD, when she says that words have precise meanings in science? For example, when it says not a force, it doesn't mean that it is a force.
I didn't say that was wrong. And I didn't say gravity was a force. I said gravity together with mass makes a force. Didn't I say that?
Yeah, but the problem we've got is if it's the curvature of space-time, it's not causing anything.
I don't have a problem with that.
Yeah, but it's the effect, though. It's not the cause, isn't it? So how does an effect cause something?
The bending of space-time is what causes what we see as things falling.
How does the curvature of space-time or the bending of space-time cause anything when it's the effect?
The space-time together with the object that creates the well creates the effect, creates gravity, and that is apparent to us when we're looking at it in the real world. I put that in inverted commas. When we're looking at it, to all the world, it looks like things falling.
Yeah,
Okay.
but it's not force, is it? It's the effect.
Okay, we can go around in circles around that. I told you gravity is not a force on its own. I said that.
Yeah. So if
Okay.
it's not a force, what changes the perigee and apogee of the moon if there's no force or gravitation? That's the key question that you need to address. But you can come back to it another time. I know you.
It is a fact of orbital mechanics that orbits will be elliptical.
Yeah. What causes perigee and apogee if gravity's not a force?
It's a much longer lesson than I could ever hope to give you right now, as I'm trying to get ready to go to work. So please, let's just carry on.
Okay, let's not get into so perigee and apogee are an issue if you're going to ask what's making the sun move. I have no idea what the sun is, let alone.
There are plenty of scientific papers you can read on that on how that happens. So you don't need me to be giving you that a science lesson right here. So go ahead and look it up. There's plenty of it.
So given that the sun must change velocity on the flat Earth model, it doesn't. It just needs to use the ecliptic path, which is what I described before. What force? Who knows? What is the sun? Why are tides independent of day?
What is this ecliptic path business? Can you explain that to me? Maybe you used that a few times now. What is it?
Okay.
What is this ecliptic path?
So let's put that's basically, let's go with the rotation or the orbit of the sun across the top of the plane. If we're going to go with the AE map, we'll go with that.
Let's go with that. Yeah. Okay.
All right. So there's the territory, the outer edge of the ice wall or whatever, and basically what goes on. The way that the path of the sun works, the way I understand it, is that the sun isn't going. The sun goes round. Let's get the sun quickly. Oh, balls, that didn't work. Let's get this quick. Fuck off. There we go.
Relax. I'm not judging you.
Fucking hell. Right, let's try and get. I'm hoping. There we go. So as the sun moves round its path above our heads, it moves round like that. But this circle itself is moving round an ecliptic path itself. So that's moving round in a circle whilst the sun is on it. So the sun is maintaining a constant all the way around its path, but the path itself is moving on a camshaft. It's called the ecliptic path of the sun. It works exactly the same on both models. Do you understand my point, or do I need to have another go at it?
No. I get exactly what you're saying, for, and I've never actually looked at it like that. I'd have to do some bit of maths if I'm going to debunk that at all. But it's interesting. I've never looked at it like that. I've looked at it really. The sun somehow changes its direction after it's finished with the summer in the north. It decides it's time to go and be summer in the south and changes direction. I've looked at it like that. I haven't looked at it from your ecliptical path. That's interesting. But can I ask you a question then? What powers it?
No idea. What is the sun?
So you don't know, is what you're saying?
I don't even know that the sun's. Is the sun a tangible object?
Okay, and you calling calling that science, are you?
We observe a phenomena. What's causing it? What's causing the sun to move? We have no idea what the sun is, let alone how we can describe how.
You want to swap. You want me and us. When I say me, or practically the entire world, to swap your don't know for what we can predict.
Okay, can I just intersect for just 1 second? Could I just intersect?
Sure.
This might sound like a silly question, but Tony just showed you the AE map, essentially, and the rotation of the sun above it. I'm just wondering why you've never looked into that, because it would seem to me if you're coming to debate a flat earther that can offer a explanation that's in every respect just the same as your explanation for the globe model, why you wouldn't have looked into that?
No, I have on many occasions had a look at how the sun models where the sun goes around the Cancer, and then changes and goes around the equator, and then in the next equinox goes around Capricorn. I have seen that many times. Okay, so I haven't seen someone described it as an ecliptical path, or I can't even imagine what that would be. But anyway, I haven't, and I'm willing to entertain the idea that that's worth looking at.
Okay, cool. Okay. Carry on, Tony.
All right, so in this one, you've put Mumbai, and you corrected yourself, and you said Cape Town, I think you said. So when in South Africa, looking south, and then in Melbourne, Australia, also looking south, one can observe both the iconic Southern Cross during the night, one can observe both the iconic Southern Cross during the night. Is that meant to be?
They're not at 90 degrees. They're about 110 or 100, something like that.
Yeah, that's an issue, right? Because what you're doing is claiming that you can stand in Australia and in South Africa, look south at the same time and see the same stars, and that works on your model. But in real world, where is that evidence that that's true?
It is.
Where is it? Because this is the key point. If you can have an observer in Australia.
It's been described many times by people. Are you suggesting you can't see the Southern Cross from Cape Town?
I know you can't see it. That's why that evidence.
You can't see the Southern Cross from Cape Town.
No, let me be really clear. If you're standing in Melbourne and looking due south, and your other guys in either Africa or in South America, whichever, they've got to look due south at the same time as you and see the same stars but rotated. Do you agree?
No, they're going to look at the same stars. They're looking south. They're going to see the same stars.
Yeah, but rotated. Do you agree?
I have to think about that.
If we're on a sphere, both people have to be looking in the same way that we look north and we see the North Star. You've also got to look south and see the South Star or the South rotation.
Everybody who looks north sees the North Star, don't they?
That's right. But your point here.
Everybody who looks south sees the South Star. Do you agree with that?
No, that's not true. Your point you're making is that. Listen, just listen to me. Your point you're making is a dude in Australia and a dude in South Africa or in South America.
We'll see the South Celestial Pole, yes.
Yeah, they might see it, but the key point is, and this is the point that makes and breaks this point for me. If I were on, right, listen, they've got to both look south. You can't both look nearly south. If we're on a ball, that south point has got to be the same. It's got to be the opposite of looking north and seeing the North Star. Because it's a ball.
Exactly.
Right. Where's the evidence? That's true.
All right, so we'll get. I haven't got evidence right now, and I don't have time to do it. But I'm quite happy. Do you want to stand on this on saying that it's not that? Because I can organise somebody in South Africa to take a picture of that, and we can do the same thing in Australia.
Well, we already know it's not true because we have to adjust.
Sorry, it's true. You can say that.
It's not because we already have to.
Okay, Anthony, let's get past it.
No, hang on.
We'll let the viewers decide that. Go on.
Well, we have to adjust for something called magnetic declination, which tells you that when you actually got your compass and it's lining up north and you're seeing where north is and you point to where south is because it's the opposing points, they tell you that you're not actually looking south when the compass lines up south. They tell you you've got to make an adjustment of about 14 degrees if you're in Australia, and that's because the southern rotation point doesn't line up. So they're telling you to go against what your compass tells you and adjust for something they tell you that's called declination because they don't line up. Now, what the question is there a legitimate reason to make declination adjustments to correct for south, or is it really because they don't line up the way that you believe that they do?
I'm afraid they do. Let's move on.
Declination is a thing. Yeah. North Pole to equator is whatever, therefore the distance is around this.
Forget about these slides. This is done in the middle of the night. I don't know whether they're good or not. I'm not standing by them, so just leave them.
Right, so in that case we're done, but you should go back to that declination point, because if you could demonstrate that you could actually look south at the same time as a dude in Australia.
Can I choose where I want to go back to? So I'm going to go back with the Earth's rotating. May I start with that?
Yeah, where do you want me to go back to?
I don't have much time, so I've got to make this quick, okay?
Tell me where you want me to go back to, and I'll go back to it.
Look, I just simply there's no particular slide, but you said that you wanted proof. You called it proof that the Earth rotates.
Yeah, scientific proof that the Earth turns.
Okay.
The phenomenon we see sunrise and sunset, right? We both agree that the sun appears to go down and up, and the cause is to be Earth turn.
Yes.
Right.
Yes. Yep.
Proof.
Correct.
Yes.
Okay. All right. First of all, can we remove proof out of the lexicon?
No, because we're supposed to have all this hundreds of years of science.
No, Anthony. I told you before, and I'm not sure which part you didn't understand, but science doesn't stand still. There's no truth in science, okay?
So we don't have all the scientific
It's
proof.
going to change.
Listen, so we don't have all the scientific proof that's claimed then, is that the case?
No, what we have is evidence.
Oh, right, so we only have some supporting evidence, not the proof, not all the evidence, all the scientific experiments and all that. That doesn't actually exist.
Anthony, this is how it works. The sun, what we observe is the sun tracking across the sky, okay? And then it sets. It doesn't seem to change its angular size as it tracks across the sky. It just simply sets in the distance, and we can see it. The sun's pretty much the same as it's always been. Okay, that's just one piece of evidence. Another one is that it takes about 24 hours to return.
Let's apply scientific method.
No, just let me just finish this, okay?
Hang on,
you wanted to. I'm giving you evidence of why we think the Earth spins.
Listen, that's not. I'm asking for the scientific proof that the Earth turns to explain.
No, Tony, forget that.
No, I'm not forgetting that. There's supposed to be hundreds of years.
Evidence. It's not how it works. You see, we're barking at different trees.
Right, so listen, we have a phenomena. We can see the sun appears to set. What's causing that phenomena? You tell us the Earth's turning. I want to see the proof that the Earth's turning. Where is that evidence, please?
The evidence is that the sun moves. The sun moves. We look, it comes up the other side.
I thought it was the Earth that moves.
It rises to the same size as all through the day, and then sets the same size.
You're saying
that is just one of the pieces of evidence.
Phil, you're
There's
saying that
hundreds of pieces of evidences. We put them all together and we say, I wonder what this could be.
Phil,
Right.
You're saying that the sun moves, are you? I thought it was supposed to be the Earth.
No. The perception is that it moves. Of course,
Right.
The sun doesn't move.
Right, so you're saying
the sun does move, but not in the way.
it must be us that's moving then, right?
Sorry?
If the sun's not moving actually, it must be us that's moving, right?
Of course, it's us that's moving. Well,
Right.
The sun is moving
Why can't-
too, but
Why can't-
not in.
Prove that. You're a PhD professor, right? Why can't you prove the science that proves that we're turning?
I've given you some evidence that we're turning.
I want the science that proves that the Earth's turning, not the evidence,
That
not
is-
the you believe. I want the science that proves that the Earth turns. Can you provide it, yes or no?
Of course.
Right. When? Can you do it now?
I've told you. You put all the evidence together, that creates a model, and then you have a look at that and say, can I use this to make a prediction?
Right. Can it be done within scientific method? Yes or
Listen,
no?
just stop for a minute. Can I use this model that I've created, I worked out that the Earth spins. Now, because of that, if I choose to understand that the Earth spins, can I use that spin to make a prediction? And guess what? I can. And let me tell you something. And I know you think this is just all nonsense, but I'll tell you something else.
No, that's called a correlation.
Do you know what a polar satellite is?
Bill, I'm not interested. What you're describing is a correlation. I'm not asking for
It doesn't matter whether you're interested. I'm going to tell the audience what a polar satellite is. Okay?
So
a polar satellite.
Bill, you're a
Goes
pseudoscientist.
around about 5 degrees off the poles, and while it's going around the poles, it goes around one track around the pole. And while it's going around the poles, the Earth beneath it is spinning. This means that the polar satellite gets to see the entire Earth about every 12 hours. So in 12 hours' time, the polar satellite will have seen the entire Earth. This is how military satellites get to see what's on the Earth. Okay?
That's a lovely story, Phil. Address.
So there you go.
Address my.
You can take it.
Phil, for fuck's sake, man, listen to me. I want you to address the criticism of your previous point. I said that you are correlating the movement of the sun with Earth turn, but you're not proving it. And we're asking for the science that proves that we are turning a smegging inch. And you say you can prove it, but when I ask you to produce evidence for it, you start describing a correlation. That isn't proof, Phil. That's pseudoscience.
Well, okay, all right. Where there's a correlation, put it this way. Let's say, for instance, we say people from China have black hair. There's a correlation, isn't there?
Seems like a non sequitur, straw man, red hair.
I'm trying to explain to you that correlation, when there is sufficient evidence, is enough to draw a conclusion.
Yeah, you can draw a conclusion, but it falls outside a scientific method and satisfies the definition of pseudoscience.
There we go again with your four corners of the contract.
Yeah, scientific method is pretty narrow. If you're going to claim that Earth's turning, and I ask you to produce proof that it is, and you can't do it, do you think I'm going to let you get away with not being able to produce it when you said you can't?
Anthony, listen to this. So, because the Earth turns, we spend $600 million putting a satellite up there that can look at the Earth, and because we rely on the fact that the Earth is turning, because the satellite can't do that, the satellite goes in one orbital path around the Earth, we rely on the Earth turning. That's how we get to see the whole of the Earth in 12 hours.
Who cares?
That's pretty strong evidence that the Earth turns.
It isn't. It's got no evidence, no strength to the value at all.
Okay. What can I say?
That the only way you can prove that the Earth is turning by logically inferring it through supporting evidence and lovely stories. Where's the experiment? There's a reason why I cited it. Listen, Phil, there's a reason why I cited that people.
Could I just intersect 1 sec again? Without you having a look at the AE map projection and how the sun moves on that, you know, if that correlation would work exactly the same. So, I mean, you're just taking one side here, what you've been told, and what we're saying is we have another explanation that would give you the same result from the same observations from what you've been seeing.
That is Shane, that is excellent. I love what you just said. And the reason I love what you've just said is because this is exactly my point. Okay? You can look at those two models, how they are, and then use either one of them to make predictions. Okay? You can say, well, I need to use this flat Earth model to make a particular prediction because it suits what I'm going to do now. It is not about the truth. It's about whether you can correlate put all this evidence together and say, look, from all of this evidence, I'm going to make a conclusion about what is exactly happening. And then I'm going to use this conclusion in a very practical way to do things like put a polar satellite in orbit. That's what it is. But that's fine. I'm happy with the idea that you can think that fine. This model, the flat Earth model, is the sun going around a flat plane. That's great and might work for some instances. But then, how does it do it without a lampshade, for instance? This is one of the questions.
Yeah, I think my point in amongst all of that was basically that you've only ever looked at one model.
No, that's not right. The flat Earth models have been looked on for thousands of years. It's just that it's no longer accepted because there's too many problems with it. That's
Yeah,
all.
I mean, it might have been looked at for thousands of years, but have you specifically looked into it? I mean, you did admit before that you hadn't.
Yes. Look, I'm a busy person. I don't spend a lot of time looking at particular models, but I can see from the ones that I have seen, I can see that that they say the Earth goes around a plane, but as far as I can see, there's too many problems with that. I spent quite a bit of time talking those first slides, and I pointed out the problems that exist with that.
Do you want to carry on, Tony?
Yeah, there's a reason why I had Lawrence Krauss on screen before. The command. Listen, when you're describing the path of the sun, and you say about all the other evidence that you can, once you get certain amounts of evidence and you can put it all together and you can make a logical point or whatever phraseology used, ultimately you're failing to comply with scientific method, because what you're failing to do is apply experiment. We want to see the experiment that proves that the Earth is turning, not the evidence that leads you to believe that. We want to see proof that we're turning a smegging inch. Because if we're not turning a smegging inch and you can't prove that we are, why would you tell people that we are when we see the sun go over our head and everything in our senses tells us that the sun's going over our head? It doesn't tell us that we're turning. But if you're going to claim that we are, we want to see the science. If you can't demonstrate
the science, Tony, the science is that a polar satellite relies on the Earth moving, and it does.
Right, that's not scientific experiment where you demonstrate a cause and effect. We do see a phenomena, the sun appears to set. We believe, or you're telling us, we're told that the cause of sunset is Earth turn. We want to see evidence that proves that we're moving a smegging inch. If you can't prove that we're moving, then it's not moving. It's the way it appears to us through the eye. The sun's going overhead. How it does it, who cares? But what we can say is we can pretty much rule out that we're not turning because nobody can prove that we are. That is the fundamental... science.
No. Wrong.
On screen. On screen.
Tony, the satellite goes from pole to pole. The Earth moves beneath it. We rely on this movement in order to the satellite to see the Earth.
It doesn't prove anything to do with the shape or indeed whether or not we're turning.
Yes, I'm afraid it does.
No, I'm afraid
because the satellite only takes one path. Okay?
But you can't prove that there's
in order for the entire Earth to be photographed, you need the satellite you need the Earth to be turning, and it does.
Right, that's an affirming the consequent. Do you know what an affirming the consequent is?
Yes, I know, Anthony. But as far as I'm concerned, that is sufficient evidence for me.
Yeah, but that's falling outside. It's falling short of scientific method, and by definition, makes it pseudoscience, fake science.
Wow. Okay. Call it fake, whatever you like. It's $600 million worth of fake. And you know what, Anthony? They get us to do it over and over and over again. We're about to do, I think, PLV.
Phil, it doesn't prove the point.
I'm afraid it does. If you know,
it doesn't. It doesn't.
I'm afraid it does. The only way the satellite gets to see the whole Earth is if the Earth moves beneath it.
I think it's time you went to work, Phil. This is flogging a dead horse. Everybody knows that you haven't demonstrated that.
You're quite right. You're quite right. I am leaving it a bit late. Okay. All right. Okay. So I just want to make a conclusion. Obviously, if people want to look back at this, Shane, you obviously be posting this, so they'll be able to look back and see what the points are.
Yeah.
Anthony, thank you for the time that you've spent talking. And although it started off as a little bit rough, it ended up okay.
You practice pseudoscience, Phil. You're a fake scientist. Sorry.
Okay.
Well. Well, I guess we're going to wrap this one up then. Is there anything that you guys want to promote, your channel or anything like that?
Look, as far as my channel goes, I will. It's a strange thing, you know. Anthony made some accusations about the fact that I posted that video up just because of this flat thing. But I'm sorry, you're wrong about that. It was an actual lecture, and I posted it because I was missing about half the class. So I wanted them to see it. Okay? So that's the reason that I posted it. Normally, I don't post them. I have posted 3 or 4 of them for that very reason, because I'm kind of very new to this YouTube thing. And I've worked out, wow, this is fantastic, because if the class misses a lecture, I can actually put it up there and they can all have a look at it. And that's the reason that it's up there. I didn't do it there. It's not up there for the purposes of flat earth debunking, okay? Yeah. It's just simply there for my students. So well, that it allows you to see.
What we do, Phil, is we tend to pin certain topics on certain people. So, for example, Conspiracy Cats has got gas pressure pinned on him because he knows he can't get out of it. And every time we see him, we ask him, how do you have gas pressure without a container? I'm going to pin the earth turn on you because I want you to demonstrate scientific proof that proves that the earth's turning a second inch. And if you can't do it, we're going to keep asking you, where's the proof?
Sorry, you're asking the wrong guy, because if you ask somebody that question who wasn't involved with the satellite industry, I would think they would struggle. In my case, I can tell you now, and I have mentioned it at least 4 or 5 times already, the Earth must move beneath the satellite, because the satellite only has one path, about 5 degrees off the poles, okay? It has to do that. The Earth must turn.
We haven't observed phenomena. You tell us that the Earth turns. We want to see the proof that the Earth turns. And that what you're doing is affirming the concept.
The satellite is the proof.
Not proof, mate.
Okay. What can I do? All right. Listen, I do have to get on. So I am thanking you, and the channel, I thank you, Shane, and the channel, Ranty Flat Earth. I quite like what you do. I think your format's great. It's entertaining. And the other thing is you're a man of integrity, Shane, and I appreciate that. Okay?
Okay, hey, Phil,
just before you go, Phil, your nickname in chat is Pseudo Phil from now on. That's what you've been tagged, Pseudo Phil.
Whatever.
Have a good day, sir.
Okay.
Okay, bye-bye, Phil.
Bye.
Holy shit, man.
Okay, well, we'll have a little chat afterwards, Tony. Hang on the line. I'll round up the show. Right, okay, well, thank you very much, everyone that tuned in. I hope you all enjoyed that. The presentation went on probably a little longer than I thought it would do, actually. But at the end of the day, we got there. Sorry, say that again, Tony.
It took him 55 minutes to conclude his points.
It did, but then again, you had a good 40 minutes too.
Yeah, but I had to get back to his points that he was making, didn't I? I'm not going to let all of his points just slide.
Aye.
You need to insist on advanced disclosure, otherwise it shouldn't happen, because, I mean, I needed to see that shit so I could give really good, like, concise points back. You know, so I've got it lined up so I can just go straight to it rather than start looking for it, because I have all these things, but it takes time to find them live.
It'd be interesting to get you two back without actually doing a presentation, just having, you know, a set set of questions, you know, gravity, etc., and see how you got on with that. You know, maybe I can put something together.
He doesn't know what science is. He claims he knows what science is, but he clearly doesn't, because we haven't observed phenomena. The sun appears to set. What's causing it? Well, they tell us Earth turn. Okay, well, where's the science that proves that the Earth turns? And he doesn't understand that a satellite point is non sequitur. It doesn't prove any point. It is an affirming the consequence. Ultimately, it's begging the question. It's not relevant, but he doesn't understand that that is basically pseudoscience. I don't know how we can maintain that position with any professionalism at all. And I'm pretty sure that all the ballers will even agree with me that that is not proving the point. We want to see Earth turn, and we want to see the science that proves it, because we do have an observed phenomena. So what's causing it? Earth turn. How are you going to prove it, guys? Because that's what we want to see.
Okay, well, in regards to this debate, I'm not going to let you say any more there, Tony. I'm going to cut you off on that. simply because he's not here to respond. So I think it's a little unfair for you to have free reign on the mic if he's not here. So, but hold on the line, Tony. I will speak to you in a second. All right. Right, guys. Thanks very much. That was Scientist versus a Flat Earther. The scientist was Professor Phil Bell, and the Flat Earther was Sleeping Warrior. I hope you all enjoyed it. I'll probably do another show tomorrow evening. It will probably be a chit chat format, 11 p.m. BST, so we can get our teeth into a little bit of things. Maybe we'll get Toadie back. Who knows? To have a little chat with Sleeping Warrior and carry on where they left off. But in the meantime, thank you for all the people that donated to the Super Chat. Sam Han again, and JQ. There's a few others. Hang on, I'd have to actually scroll through to find everybody and thank everybody. Skeptic936 was another one. I'm sorry if I've missed anyone else, but I did thank you in the chat too, so at the same time. Yeah, so this will be rounding up now. Thank you very much, and I'll see you all in the next one.